We are live now. Yeah, perfect. Awesome.
Cool. So, all right, let me quickly share my screen. Yeah, can you see my screen?
Yeah, I can see it.
All right, so we're gonna start with some updates around Langbase, what we have been shipping recently, product updates, improvements. So, starting off, we have added support for a bunch of new LLMs, and we also have some new LLM providers. Uh, we recently added Open Router to our ever-growing list of LLM providers. It is a unique LLM provider that offers routing of models to ensure you get a better uptime. So it has 300 plus models in this catalog, and all are accessible on Langbase today. You can also visit our docs and see all of the supported LLMs and providers. We are always updating them. So if you do have a request around these, around a provider or a model, feel free to send it over. We take these requests very seriously. Um, yeah. So other than that, we have also made performance improvements to our memory agents, making them faster, improving their CRUD operations. And we have introduced something called memory filters. So if I show you quickly, so yeah, so filters basically allow you to narrow down your search query whenever you are retrieving knowledge from your memory. So let's say it basically works like an SQL where statement. So you can basically, while retrieving knowledge from your memory, you can use filters to further refine your search query. Uh, Let me actually show you an SDK example. So this is our SDK repository. Inside this, you will find our examples from Node, and we cover basically almost all the operations we do. So let me start with the retrieval. This is the basic retrieval without any filters. So I'm basically retrieving similar chunks from this memory and against this query. So I'm asking what are pipes in Langbase. But with filters, what I can do is I can basically ask it to narrow down this results based on operands like and or in equal. For example, I'm going to ask what are primitives in Langbase, and I'm going to assign some filters. These filters basically are doing is they are ensuring that whatever chunk you give me back, it should have the company Langbase, it should have the category of docs or examples, and it should be only concerned with chunk or thread primitive. So it's going to narrow down the result based on these filters, giving you a better response, more relevant chunks, basically ensuring that you get a better response. So we also have negative equality filters like not equals base. This is a very useful filter. For example, let's say you have some text in your memory which you don't want to use right now. You don't want to retrieve chunks from that particular text. You can use this filter and it will make sure that it won't include this chunk. So this, so yeah, that's how you can use memory filters. We have examples for every operation here. Feel free to check them out in our Language SDK repository. Uh, yeah, speaking of memory, we have also updated our memory configurations. These include chunk size, chunk overlap, and top K configurations. So now you have better control over the response you're getting from your memory. Let me quickly show you what it looks like. Yeah, memory create. So yeah, we have updated these configurations, including chunk size, chunk overlap, and top K. You can view it here in its API reference. Other than that,
Bilal,
several,
Bilal,
yeah,
Bilal, I have a question here. Like, what do
sure.
you recommend someone who is probably a beginner and wants to create an AI memory? What should be the default chunk size that person should use? Like, I assume the default is 10,000. Do you also like recommend any other number? And
No,
why should
actually,
the
we have,
user?
yeah, so we have spent decent amount of time deciding what will be the best defaults that cover the most use cases. And I think that if you are starting over, if you don't want to indulge yourself with these details, yeah, I would suggest just go with the default values and build on top of it. So test it out, see how it goes.
Awesome. But user can edit as well, right?
Yeah, sure. It
Awesome.
basically depends on your content, the type of content you're feeding into memory. So if you are feeding some sort of documentation, you will obviously have to set the chunk size relevant to that. And same goes for top K and other relevant values.
Yeah, I assume like I think with 10,000 chunk size, when you are using, like, let's say I'm feeding my company documentation, I would want to have at least one page part of one chunk. So if I keep the chunk size smaller, it would like one chunk won't contain my entire single one page of my documentation. So if I have like if I make it like for example 10,000, so one chunk will contain one page of my documentation. So that way, LLM will have all the information to answer the user question around, for in this particular example, what is, what are the default value of a chunk size that language memory offer. So if the chunk size is not 10,000, then probably it's, let's say it's 256, then probably the first three chunks, if you're feeding three chunks to LLM, that those three chunks probably won't have the default chunk size. So yeah, that's there as well.
Yeah, I agree. So when deciding the chunk size, our thought process is that each chunk should contain the most amount of relevant information based on
Yeah,
your code. So when you're looking at documentation, for example, that chunk size would probably be the whole page of that documentation, right? So
exactly.
yeah, it depends on on the content you're feeding to your memory, but yeah, you cannot go wrong with 10,000 chunk size
Mhm.
unless you have a specific use case. So yeah, it's a good starting point. So speaking of updates, we have also made several quality of life improvements, including a caching overhaul with improvements to request latencies, bunch of UI and UX improvements. Um, Another interesting major thing is we are launching AI primitives. So AI primitives are robust, scalable primitives which are A, really simple to use, and B, with world-class developer experience. So, as you know, this is the year of AI agents. Everyone is building AI agents, and excuse me, this is the year for building AI agents. And the concept behind these primitives is that you can build your AI agent or a multi-agent complex agentic system using these primitives. So every primitive gives you granular control, is serverless, and hence highly scalable. And basically, you can you can arrange these primitives the way you want. You can have your own logic between every single step. For example, we have chunking, which converts a document into small chunks. We have embedding primitive, which basically takes these chunks and converts them into vector embeddings. We have parsing, you know, take it can take a file like this and parse it so it is ready for further processing. We also have threads, which are basically used to maintain the conversation history of agents. So if you're building a chatbot agent, like let's say if you're building coding agent like Lovable, you want to keep the context in its conversation history. You want to save it. Threads API provides that functionality where you can store your conversation history and sort of build on that. So, Saad, do you want to expand on this functionality, what it does?
Yeah, so basically, every chatbot out there that you want to build, like for example, if it's excuse me. So, for example, it's ChatGPT or like Claude or like any other, you know, chatbot. All of these essentially uses like threads, and behind, to maintain the conversational history, as Bilal just mentioned. So essentially, like if you want to build something similar, for example, you want to build, let's say, a coding agent, just like Livable or Bolt, you would need a place to maintain all the users conversational history. And also, like for example, if you're building a multi-agent architecture where one agent is maintaining a conversational history, the same history is also needed by another agent. So this particular threads API, threads primitive, as we like to say it, you can use it to have all that data, persist all that data, and give it across different, give it to different agents, or use it in in a single agent, if you like.
Awesome. So, yeah, basically covers the conversational history part of an agent if you're building a chat related agent. So, yeah, we are moving towards AI primitives. We have launched a couple of them, and we are there are lots of them in our pipeline. So, this is another exciting thing for us. Uh, it basically primitives basically unlock all AI agents you can think of because you can arrange them, you can put your own logic between each step, and you can process them the way you like. So you are unblocked for any use case you can think of in your AI agent.
Essentially, like I would like to add to Bilal's conversation here, like just like you build like, let's say, a microservice, or let's say a backend system. You design it first, you have an architecture, and each architecture component is some kind of primitive level thing that you are using to in order to build that system. Similarly, exactly that, you build an agent, you design it first, and during that design, that fundamental component that that the agent use in order to it have a fully functional agent in the end, that fundamental components are these primitives that you can use to design an agent architecture and eventually build that agent. So yeah.
Awesome. Uh, yeah. So that was a short rundown of what we have been up to. Uh, yeah. So now I think we can take questions that were submitted to us beforehand. Yes. So do you wanna?
Yeah, of course. Like we opened a form and we got a bunch of questions from the community, and I have some of them here in front of me. I can just take pick the first one. So
I
the
think we
first one
can
we
go.
have,
I think we can go from the bottom up, if that.
bottom up. Uh, as in, like, do you want to go with the last question first?
Yeah, that works.
Awesome. Okay. Sure. So we have a question like, can I attach multiple memory agents to a single pipe agent? Um, Bilal, do you want to take this one?
Sure. So the short answer is yes. You can attach as many memory agents to a single pipe. Uh, in terms of best practices, you want to arrange your memories meaningfully, right? Uh, so the way you divide your data into different memory agents will actually impact your response efficiency and accuracy. But yeah, you can definitely attach as many agents of memory to a pipe. Yeah.
Awesome. Yeah. So as Bilal just mentioned, attach as many as you like, but be very careful. It may affect it may, it may affect how the, agent will work, because at the end of the day, you need to be mindful about, your agent logic, and, how the memories are arranged, how the data is persisted across all the memories. There is another one around memory agent. I see there are a bunch of questions around memory agents. I think people are really curious when it comes to memory. There is another question: do we provide an API for our memory agents? I can probably take this one. I can probably, take this one. Yeah, we do provide API for our memory agent. It's actually, we provide all the, like, you can create a memory agent. You can upload documents to it. You can, perform retrieval. You can do all of that via the memory API. And maybe Bilal can show the API reference to quickly go over all the memory APIs that we offer.
Yeah, sure. So the idea behind memory is you can first you create your memory with your docs inside, and then there is this the basic list and CRUD operations like list and delete, and the retrieval part is where it actually comes along. Basically, so you send a query, and the memory agent matches the query based on your configurations and gives you back relevant chunks around it. So yeah, that's how it works. As you can see, there are code snippets around, as simple as a basic HTTP request or Python or Node.js. Again, I would recommend going to our SDK repository, the Langbase SDK repository. We have examples around each operations of memory agents, whether it is create or retrieval. We have a bunch of retrieval examples. You can actually run them. Just clone this repository, navigate to this example folder, and you can follow the README guide to running to in order to run these examples. So
Yeah,
I would recommend these, running these examples once to get a hang of it. And yeah, Language SDK basically makes it easier for you to do all these operations. Yeah.
yeah, a couple things to add here. Like with memory, I think like people, like, I'm really curious, interested in the retrieval, because I feel like that's where the magic happens, where you can, just give your memory a query, and you can get the similar chunks. So that's really interesting. The other part is, since we offer API, you can use it across any programming language there is out there. You can use it in Python, you can use it in PHP, whatever the language there, whatever language doesn't matter. However, we do provide JavaScript and TypeScript SDK that you can use to quickly, uh, start using these memories, start creating them, deleting them if you like, uploading documents to them. So yeah, there's that. Another thing is, like, just a quick heads up, because it may be probably not with the, you have to, like, right now go into the examples SDK, and then into examples, and you can then see all the examples, right? So we are also going to have all these examples soon in our documentation, so you can, quickly go over them, even run them. So yeah, that's coming, so just stay tuned. I think we can
Yeah.
go with the next question now, right?
Yeah. So let me ask this
uh
one to you.
yeah,
So
perfect.
why should I store information in the memory instead of feeding it to LLMs directly? And I think this is an important question
That's, yeah.
since recently LLMs have gotten ability to uh, take in more context than they were before.
Yeah.
Some Gemini models can take up to a million context in terms of tokens. So yeah, what's your take on that? Why should we use memory instead of just
yeah
throwing
that
all the documents to the LLM? Yeah.
Yeah, that's actually a very fair question. In fact, I got the same question in another meetup where I was speaking at. So the short answer is, for better performance and and cost efficiency. because every like with LLMs, LLMs have actually input token cost and then output token cost, right? In this in term of like putting all the text in, putting everything in the LLM's context, what will happen is with every request you will be sending lots of lots of tokens to the LLMs, lots of content to the LLM. So with every request, and essentially if you're maintaining a thread, then that thread will grow like so much. And with every subsequent request, the token length will grow, and eventually there will be so many costs that you will have to bear at the end. But with memory agents, and sending the relevant chunks to the LLM, what will happen is you will only send the data that actually has answer to the user query, instead of sending all the data. So sending the relevant chunks will not only saves you money, but also it will be more efficient instead of sending everything. So the short answer, for performance, for efficiency, and yeah, that is something that you should carefully think about, especially in terms of like with every request, LLM cost will increase. So yeah, Bilal, do you want to add anything?
Yeah, I totally agree. So basically, it saves you cost. It reduces your latency, which is very important, especially if you are building a user-facing agent. It, uh, I think, it also ensures less hallucination. So by only sending the relevant chunk to the LLM, you are eventually making sure that the LLM responds from that similar context, not from other relevant data that is not going to be correct. So yeah, while you can
Mm.
send large amounts of data to LLMs today, it may not be as efficient as it is when using with memory.
Yeah, 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 exactly.
Right.
Um, I think we can move on to the next question,
Yeah.
because the
So
question we have, yeah, sorry, go ahead.
yeah, so I see a couple of questions around vision and OCR. Uh,
Yeah,
we should take them on. Yeah.
yeah, perfect. Yeah, I was about to take that one. So I was about to ask you that one. So basically, we someone asked, is it possible to do OCR with vision models in pipes? Yeah,
Sure. So we do support vision, and let me quickly do a short demo of how you can use vision for OCR related tasks at Langbase. Quick intro, what is vision? So these are LLM models with vision capabilities. They can basically take image as input, and they can analyze them and return text as response. So one of those use cases is OCR. So you want to read stuff from an image, and classify it, and do other fun stuff with it. So yeah, let me go ahead and create a pipe for vision here. Let's call it vision. So what I'm going to do is basically select an LLM that supports vision capabilities, and then we are going to try sending a vision request, see how it does. All right.
yeah,
So
awesome.
all right. So
That's
I'm gonna
good.
keep it simple. Just select a model that supports vision. Yeah. So GPT-4 Mini does support vision, as you can see here. So I think this is good to go. Let me go here and actually copy the curl statement without string. So to quickly test it, let me pull up Postman here real quick. Yeah, I'm just gonna paste the curl statement here. It's going to auto-populate everything here. So for vision, you basically send the image or its URL inside your message to the LLM, and you can basically ask it to analyze it and do stuff with it. So we're gonna use our guide to see how that works. Yeah. So basically, inside a message, It's going to be a user role message where you can ask a text related questions like what is this image, and you can uh, provide the image URL in the next object. So you can send the image in two ways. It can be a base 64 encoded image. Base 64 is supported by all providers. Uh, OpenAI also supports public facing URLs where it goes and fetches the image for you and um, you know applies vision on it. So I'm gonna copy this part here and just paste it in. Okay. All right. Uh, Looks good. It is asking to describe this image. Let's run this request.
By the way, while okay, it's here.
Yeah. So as you can see, it basically analyzed the image and gave you the response that okay, this image features a close up of a vibrant green bee and whatnot. Uh, yeah. So I think this is the one. This is the image we sent here. All right.
Perfect. One thing, Bilal, I think everyone saw your pipe API key, so maybe rotate it.
That's fine. This is just a demo pipe, and I'm totally going to delete it after the stream, so we can
Awesome.
try it out.
Awesome.
But yeah, in production, make sure you never expose your API keys anywhere.
Yeah, please do not expose your API keys. If someone has access to them, they can just quickly run your agents.
Right. So I do have another. So let's actually test OCR, right? So let's test something like handwriting in an image. Let's see if it recognizes it. So
Yeah, that would be fun.
yeah, I'm gonna go off and try to find a picture with some handwriting on it. Just give me a second.
Did you write something and then take a picture beforehand before the
That's a
stream?
possibility. But yeah, just give me a second.
Awesome.
Okay.
Awesome. We are folks, like if you guys have any more questions, you can again just put it in the YouTube chat box. We are live on YouTube. You can just put your questions there. If you're watching from Twitter, you can also put some questions there as well. We will just answer.
All right. So I think I have found one. Uh,
Yeah. Uh, in the meantime, while Bilal is finding an image of something he wrote before the stream, we can probably, I can probably share some things about memory because we also have a question around what is a memory. So essentially memory is just it's an agent. We are calling it a memory agent where you can put whatever kind of data you want. You can train it however you want uh, with any kind of data. It's your personal data, and then you can just start asking questions from it. You can perform retrieval, and behind the scene we are going to take care everything for you, like from parsing to chunking to embeddings, all those fun stuff. We are going to take care of it, and you can simply just you know put your data inside a memory and upload them via API or via our studio, and then you can just start asking questions from it. So yeah, that's a very brief introduction on memory. While Bilal was trying to find the image, we can touch on it later if you guys still want to know a little bit more about it. But yeah, I think Bilal has found one.
yeah. Found it. So all right. So we have some handwritten text in this image. Let's try feeding it to our LLM here. Let's see how our pipe does vision on it. And I'm actually going to change the query on this. Let's just say, give me back the text in the image as is, right?
So now it's going to perform OCR on the image.
Yeah, that's the idea. Let's see how it does. Live demos fail all the time, but yeah.
Hopefully not this one. Hopefully we are saved.
All right.
Uh,
So yeah, that's pretty good. Yeah.
can you zoom in a bit? I think like it would be, yeah.
Okay, wait.
I think just command plus plus
Yep.
command. It should probably should zoom in.
So
Yeah,
yeah,
perfect.
if you can
I
see,
can easily see
it
the
did a
response.
perfect job. Yeah, it did a perfect job, and I don't see one mistake. So that's the idea behind OCR with Vision. It makes Vision, uh, but Vision makes OCR very easy to do, and we have seen some of our users do extremely, bulk tasks with Vision, and I think they don't cost as much as some OCR applications that used to exist before, which is crazy to think of. But yeah, so that's Vision for you, and you can try it out with your images through Base 64. You can also do fun stuff with it. I actually had the detail part set to low, so you can set it to medium and high to even further improve your responses. But yeah,
Yeah, so essentially, if you're building an application that will require user to upload some information, probably if it's probably some where they have to take a picture from, from their mobile phones, probably a picture of some letter or picture of some card they own, and you want to read that information, then all you have to do is just give it to a vision model and ask it to perform OCR, and it will just give you all the information in its response. And yeah, it's as simple as that.
yeah, awesome. So we do have one more question around structured outputs, and so they're asking how they can use structured outputs in pipes, basically. Uh, yeah, let me quickly show you. So I'm going to go ahead and open up the Langbase SDK examples. We do have an elaborate examples around every operation, including structured output. So, quick rundown of what structured outputs mean. So, we used to have a JSON board, a simple JSON board where you will essentially prompt the model to enforce it that okay, respond in JSON format. But structured outputs is the next step from that JSON board, right? So it basically ensures that the model will generate responses that adhere to the schema that you give it to. So what you do is you supply a specific schema of what you think the of what you deem the response should be, and the LLM will reliably ensure that it responds according to that schema. So looking at examples from here, you can do stuff like data extraction, you can do UI generations, moderations, and other fun stuff. So how you provide schema is something like this. So can you see this? Okay, let me zoom this. So basically you give it an idea of what your response should be. You give all the parameters, their types, and as a result it gives you back a type safe object which adheres to this schema. So let's do a quick demo for this. I'm going to use this chain of thought example. Here's the schema. All right. So we do have this example in our SDK repository. So the first step here is to create a pipe that has JSON mode turned on and the response format defined for this particular example. So it's basically a math tutor like example where it essentially takes a math question and responds in a series of steps. Every step has an explanation and an output attached to it, and finally it gives a final answer. You can also define your response format through Zod, and transform it to the JSON schema using something like sort to JSON schema library and provide it here. But we are gonna keep it as simple as possible for this example. All right, so we are gonna create this pipe first, and then we can run it, ask it a question like this. So let's go ahead and implement this real quick. PPMI pipe dot. This is how you run the examples in our SDK repository.
I think it's pnpm run, no?
Yeah,
Pnpm I will install.
yeah, right. Should run it. So right now it's gonna go ahead and create the pipe. As you can see, it created the pipe, and there you
Again,
go.
there's a pipe API key which Bilal will later rotate.
That's fine. These are demo pipes. All right. So let me quickly replay this slowly. So it went ahead and created the pipe using JSON mode turned on with structured outputs defined as a schema here. And then in the second step, I asked it a question, ran the pipe using this question, which is, a standard math question solving for X. And it gave me back, this is the response, right? This is typed exactly in the format we asked it to. So there are a series of steps. Every step has an explanation and output at that step, and it continues until it gives us the final answer. So this is a chain of thought example as well, right? So it basically divides this response to a series of steps, explaining what it is doing in each step, and gives you back a structured response so that you can format it and render it accordingly. Let
I
me
have a
run it.
follow-up question, Bilal.
Yeah, sure.
Like earlier, we just talked about vision and OCR. Can we, combine OCR, vision, and structured outputs all together and get a response in particular, like in this particular format? So, yeah, I think this will be super powerful because, when we are reading something, some data off of an image, we would like to have it in some kind of format, right? So yeah, what do you think?
100%. So it can be very useful for extracting data from an image in a more refined sort of formatted way so that you can render it in your application more reliably. I think there was an example around it as well here. Uh,
I think that this would be like super powerful.
right? So yeah, this is the example. It basically is extracting data from a research paper in certain properties, defined structure of the response. So yeah, you can theoretically define a response format for your image and combine vision with structured output. It's definitely possible.
So basically, essentially, if someone is building an application where the end user has to, take a picture of their, let's say, of any car, let's say for their driving license, we can use that person can use OCR with vision models and structured outputs in order to read what's on the card and have it in a structured way of name of the person, expiry date of the card, stuff like that, and just take it from there. Awesome.
Exactly, yeah. I think that's one of the use cases around structured outputs. And the fun part here is you can actually ensure, like, you can throw an error if it does not respond according to your schema, right? So what I have done here is I've defined the schema above here using Zord, right? And when I get back the response, I actually parse it against the schema. So in case the schema somehow fails, it will just throw an error, and I will know reliably that okay, this is not the correct solution, not the correct answer for this question.
Yeah, awesome. So Bilal, there are a couple more questions here as well. So let's take a
Sure.
look at them too. So I think there is a question around can I use Langbase pipes and memory agents in Python? Uh, Short answer, I can take it like short answer is absolutely. We offer API like on top of the SDK that we provide, which is right now TypeScript and JavaScript SDK. We also offer an API, so you can use that API in any language that you probably working in, and start building applications. And all the primitives that Bilal earlier talked about, they are also going to be available on API. So it's not just going to be on our SDK. You can use them if if you are probably, let's say, working with PHP. You can use them. You can use the same primitives and build the same AI agent, probably in PHP. Then using our API. Also, like we are in process of launching our Python SDK soon. So if you guys just wait, and we are in the process, and we will launch it soon. So yeah, it's in the making. We have like a lot of people have reached out to us, for this particular with this particular feature request. So yeah, but for now you can use the API.
Yeah, and if you do want to, subscribe to Langbase, get to know its updates, follow the Discord link below, and we do announce when spicy updates like this are live.
Yeah, please go ahead and become a part of our community. And if you're watching it from Twitter or X, you can just follow us on, our social accounts. And if you're watching it from YouTube, please go ahead and subscribe, so you get notified of all the upcoming releases that we are going to be making in the next couple of weeks. Uh, I think we have one more question, and probably we can wrap it up if no one has any more other questions, probably in the chat box and everything else. There is a
Yeah,
question around what is tool calling that different LLMs offer? I think it's a really interesting question, especially because it's make all the agents so powerful. Lal, do you want to take this one?
sure. So, right. So tool calling, if I'm not wrong, differs from provider to provider, right? OpenAI would offer, I think it offers parallel tool calls differently as compared to what Anthropic does. So, yeah, let me quickly go here and show you the tool support of these. Yeah. So, yeah, Sat, do you want to expand on the difference between parallel tool calls and just simple tool calls?
Yeah, of course, of course. So, first of all, like let's quickly talk about what actually tool calling is, where it is essentially you are telling LLM that, if a particular thing happens, instead of generating a response, just tell me that I need to run this particular function in my code. Let's talk with example. uh, LLMs do not have up to date information, right? Up to date information, like they have a context. They have the training up to like where the month, etc., where they are trained on. So afterwards, they don't have any information. They don't have live information on top of it. So if the user goes and asks, "Oh, what's the weather in San Francisco?" the LLM won't know. But what if there's a way to empower LLM that it can know about what the weather actually is in San Francisco? And that way is actually using tool calling. And with tool calling, what happens is you give the LLM a format of a tool that, okay, you can also see in on the screen that Bilal is showing up, that we have these tools array where we just give the LLM a definition of a function that we have in our code base. So essentially, like with function, there it's gonna be get current weather. It's gonna have a description like get the current weather of a given location. So this part is really important because this actually helps the LLM to realize, I need to, when the user is going to ask me whether I need to run this particular function. So the description is really important. And then it's going to have some parameters like, properties it's going to take, for example, unit or location, etc. So, and among these two properties, the required one is location, because we need a location in order to, find the weather, right? So now, since we are going to be passing this definition, tools definition, with every LLM request, we are going to be sending this tools definition to with every LLM request. Uh, what will happen is, if the user asks, okay, what's the weather in San Francisco? What will the Instead of generating a response like, I don't have the live data, LLM will instead, instead of generating this response, LLM will just send us a format that, okay, you need to run this particular function, get current weather, and it will also tell which arguments you need to run the function with. For example, the location is going to be San Francisco. So you can just check for it, have a check for it, like we have here. We provide a helper function in our SDK, where you can just send the response, get tools from runs, and if there are tool calls instead of the response, we have a if condition in our code, where we can just, since tool calls is an array, we you can just iterate over every you can just iterate over this array and call every tool that the LLM has called. In this particular situation, get current weather function. So you can just call it, you can just use some API inside this. Since it's essentially a function in your code base, you can just call some API in that function, get the weather of San Francisco, and give it back to LLM. And the LLM will respond, oh, the weather in San Francisco is, let's say, 65 Fahrenheit. I'm not sure if it's the 65 Fahrenheit there, but you get the idea, right? So it actually makes LLM super powerful to, work with different external APIs. Let's say you want to fetch
Yeah,
some emails you want the LLM, you ask LLM, oh, fetch top 3 emails from my inbox and tell me if I need to respond or not. You can give LLM a tool into fetch that email, because LLM don't have access to your Gmail account, but instead you can just write some logic in a function to fetch emails and give it as a tool to LLM, and LLM will use it to fetch the emails. And essentially, the Bilal asked about what's the difference between parallel tool calls and simple tool calls. The difference is that with parallel tool calls, LLM can make multiple tool calls in one single response. For example, user asks, "What is the weather in San Francisco?" And in the same prompt, the user is asking, "Also, tell me if I need to reply to the first email in my inbox." These are two separate operations that may require two separate tool calls. So with parallel tool calls, instead of calling one tool at a time, LLM will respond with both tools at the same time, so you can just run them on your side one at a time, and combine the response and send it back to LLM. So your LLM is actually calling all the tools at once. But if you turn off that parallel tool call, that won't happen. LLM will call one tool at a time. And yeah, probably that won't be ideal, but there are some use cases out there where the user wants to have one tool call at a time.
definitely, especially if you are, in conversational agents, or if you want to execute a task step by step, where the second step depends on the first step's answer. So yeah, that's when you want to turn the parallel tool calling off. But yeah, tool calling is extremely powerful, especially in cases where you want to connect your agent to uh, something inside your system. So you want to fetch something from your internal database, but without giving the LLM access to your whole data. So you just basically define a tool that will translate into a function call inside your database. Uh, uh, the model context protocols are, I think it's also based on tool calling, right? It's
Yeah,
extremely powerful,
exactly.
and bunch of use cases, and it's all based on tool calling. So it's just uh, tool calling is just that powerful.
Yeah.
Yeah.
Awesome. I think that's about it. Bilal, do you have any questions that
Yeah.
we can
Uh,
answer, or any updates? that we can share then?
Yeah, so feel free to share more feedback about the developer office hours, the format and whatnot. We would love to hear your feedback, and we would love you to be champions of our product and help shape the improvements and help us define our roadmap better. Uh, best way to do that would be joining the Discord, and uh, you know, we always appreciate what your use cases are, what you are building, and how we can enable you build better. So
Yeah.
yeah, that's pretty much from me.
Yeah. Yeah, also, like, please go ahead and become part of our Discord community. You can see the link down in the stream. Uh, and if you have any feedback, you can reach out to us there as well, or you can just, subscribe to our YouTube and get an update on everything that we are going to launch in upcoming weeks.
Awesome. So I think that was it for today for the April Developer Office Hours. Uh, See you guys on Discord and probably the next Developer Office Hours.
Awesome. Awesome. See ya. Bye bye.
See you guys.